Hey everyone, Greg here. Let me move that out of the way. And welcome to our week 7-8 transition video. Just a beautiful day in Oregon today. It's the reason why I live here. Had a good ride. I think it was almost 80. And anyway, just a beautiful day. Well, here we are. We're headed into the last week and it's final project time. And I know you're getting tired, but this final project is the real culmination of the course. And as in all the Concordia courses, the course is designed to point you directly towards your dissertation. So this simulated Chapter 3 and 4 methods section is really what a Chapter 3 and 4 methods section will look like in a dissertation. So I sent you that model, and I'm continuing to upgrade that model, although it's pretty close the way it is. I think the one that you have received about a B+. It's really well done. There's some things that could be a little bit better, but you have a week. The first thing to note is it's totally okay to follow that model in terms of headers for your pages and your subheadings. In fact, that is APA almost exact. So yours needs to look that way in terms of headings and subheadings and spacing and all that stuff, because that is APA. The other thing is, and so just use exactly what you see there. The other thing is each heading, which each part of Chapter 3 and 4 has to be completed. You can't leave anything out. All the different sections of it have to be completed, and that's also in the assignment in the course. So those two things are important. Now, one of the things that I've had a couple conversations with people, looked at the first drafts. We're still at the point where we're just learning, and if you look at that model research paper, you will see that it has one thing that is critically important. When the author states a research question, following the research question, there is a testable null hypothesis, and the two are very different. So, a research question might be, is there a relationship between a student's learning time and academic performance? Well, a research question is just a general statement of kind of causality or kind of association that you want to investigate. That's what a research question is. The testable hypothesis that answers the research question is quite different. So in that case, the testable hypothesis would be, and then you have to label it HO, there is no correlation between the number of hours a student is in school per year and the score on the state-mandated test. Now that's a specific correlational null hypothesis. So you're gathering 30 students and you're finding out the number of days they were in school and their score on the state-mandated test, and you're running a Pearson's correlation coefficient on that data. And by the way, the data has to be in the paper so I can verify that in that case the R and the P value were correct. Now for every null hypothesis you have an alternative hypothesis, which is that there is a correlation between those two, and it's worded the same thing. But the alternative hypothesis is sometimes called the research hypothesis because that's what you're hoping to find. You're hoping to find a correlation. Alright, so if you look at the paper I sent you, there is a clear ratio of research question, testable null hypothesis, alternative hypothesis. Research question, testable hypothesis, alternative hypothesis. It's the null hypothesis that you test with one of the statistical tests to see if you can reject it in favor of the alternative hypothesis, which lends support to your research question. So look very carefully at that model. So another example would be, you're probably only going to do two things. Most people are only going to use t-tests to compare means of different groups, or you might use correlation. So here's another example of a research question. And again, a research question is very general. Does participation in school activities increase academic performance? Now, that's just a general idea of cause and effect with no way to test it. The way you test it is with a testable null hypothesis, which could be there is no significant difference between the mean GPA of students who are involved in activities 2 hours per week or more and those who are not. So you clearly have two samples from two groups, and you're going to run a two independent sample t-test to see if the means are different. And if the means are different, which means you're rejecting the null hypothesis, then you have evidence for causality, but you don't have any conclusive proof. You just know that one group scores higher than another. Now, since it's not an experiment and it's causal comparative research, you don't know if there's a cause there, but you do know that one group is different from another. And the classic example of that is, does smoking cause cancer? Well, of course, smokers have higher rates of cancer. We know that, but that doesn't mean smoking causes cancer. Now, of course, you think, well, it's got to. Well, and it does, but you can't assume that. That was done experimentally. All of the smokers in the United States are not different than the non-smokers in only one aspect. Only an experiment can show you that. So I don't think anybody will be doing an experiment. Experiments aren't done too often in education because you can't manipulate independent variables. You can't subject one group to different types of teaching methods or a better diet or something like that. So generally, we're looking at causal comparative designs or correlational designs. Now, I can't emphasize, people get towards Thursday and then they ask me, can you look at this? And there's just almost too much to fix before Sunday. So we need to start now. And I really think the easiest way is if you share it if you put it in a Google Doc, and then we have a phone conversation and we talk about it, it's much easier to look at it and to fix the ideas there. Then before you submit it, you can put it into your Word doc, and it has to be uploaded to TaskStream. So I'll go through how you do that. TaskStream is the mechanism by which you submit your final work, and it goes into Concordia and it's saved for accreditation purposes and all of that. So it's a big week. There's a lot to do. So start with that model and get a start on that. And then the other thing is be succinct and don't be real long-winded in those sections. So, for instance, what are your threats to internal validity? State them very clearly and know what internal validity means. What are your threats to external validity? Do we know the difference between internal and external validity? Internal validity means you've done if you run an experiment and you want to see if eating Skittles increases performance on a spelling test of third graders, and you don't have a control and experimental group, and the group eating Skittles is in a room with more light, then there's a threat to internal validity, meaning you're not going to be able to show that eating Skittles causes an increase in performance because there's too many other confounding variables. So that's called a threat to internal validity. You're not able to show what you want to show for that population. A threat to external validity means you're taking a sample and you're analyzing a small sample of the wrong population. So if you say that eating Skittles increases academic performance and you've only run your experiment on students in some small town, then that isn't going to apply to all of America. So that's like going to Idaho and asking who's going to be the next president, or going to LA and asking who's going to be the next president. Your results won't be externally valid because the sample frame is wrong. So I'm going to be ready on the phone all evening, Monday, Tuesday. We've got a few ready to go. And any way I can help, this is the week. So thank you very much. Okay, have a good evening.